So in this project, we used a sound module to detect the amount of sound or decibels present. So we start off by defining the D-serial or serial USB to use the input information and display in the serial monitor. Here we define the pin PA6 and pin LD125. And we need the integer for the analog pin, which is A0, sensor digital pin PA6, an analog value 0, and a digital value. So we have two options here. We can either use an analog pin with an analog value or a digital pin with a digital value. And these would just have different formats and work in different ways. And in void setup, we want to start up our serial monitor as well as define which pin is an input and which pin mode is an output. And here in the loop, we start the analog read for the analog pin, so we want to check if there is any information from the analog pin or digital pin. And we also want to print all this information in our serial monitor. And here we have an if statement. If digital value is high, then digital write is high as well. Otherwise, we want that to be low, and we have a delay here. And so it's also written here so we don't overwhelm the serial interface. And if you want the data to be put even slower, you can just increase the delay as well. And yeah. So in this project, we use a sound module to detect the level of decibels present. And we can do this by using a simple circuit and 3 cables and module and breadboard. So these two cables right here, the red and orange ones, are used for they're used for the ground and voltage, while this green one is for the digital signal. And what this allows it to do is that every time there is a sound present, what happens is it'll take that electrical signal, transmit it to this microcontroller, and it could be read from the script in the IDE, it could be read there and put into the serial monitor and show this chart right here. So for example, if I talk right here, the decibel levels will go up and down as the pitch changes. And if I stay quiet, you see it dropped all the way down here. And yeah.